So we left off with Mycobacterium, one of the gram-positive bacteria, bacilli, that doesn't have an endospore. And again, there's easily 75 species or more of Mycobacterium out there, but there's really only 3 that affect humans. The first, most common, the one you may have heard of the most, is the Mycobacterium tuberculosis. Usually we just shorten it to TB. Now there's 3 types of tuberculosis, and really even though it's all the same bacteria, it's just talking about kind of what damage, how much it's progressed in the body. There's primary, secondary, and disseminated, and I'm going to kind of flip back and forth between this slide and the next. Primary tuberculosis is an initial infection. It means the bacteria, and I might have gotten into the alveoli of the lung. They get ingested by white blood cells, but they don't die inside the white blood cells, and so they grow and form this big clump of white blood cells that are all infected with bacteria. That's a tubercle. And so these big alveoli, these big airways that we're supposed to be getting oxygen from and getting rid of carbon dioxide, is now full of these big growths of contaminated or infected cells. That's primary tuberculosis, and I'm like, it's just forming these tubercles in the lungs. What happens with the secondary or reactivated tuberculosis is that tubercle of infected cells ruptures and it spreads bacteria into neighboring alveoli. And so it's secondary. I was thinking like it reaches to a second alveoli, or reactivated, it's spreading. And I'm like, but it's still staying in the lungs. Now, the disseminated tuberculosis means that bacteria is now going to travel to other parts of the body. Those bacteria have just not gone from one alveoli to the other. They are really getting into various blood vessels and are spreading. They are spreading to other parts of the body. And so when it has officially left the lungs and traveled to other parts of the body, we call it disseminated. Places that seems to like to go the most, it likes to go to the spleen, it likes to go to the kidneys, and it likes to go to the brain. TB is it's a really common disease that HIV patients seem to contract. They just don't have the immune system to fight anything off. Their white blood cells are just going to be dying, and they're going to be spreading it. Now, interesting little part in why I had my bacteria over here holding a cheese is that this tubercle, as the inside part of the tubercle, this big clump of infected white blood cells, eventually these white blood cells are going to die. And they say that this tubercle itself, this big hard ball of infected cells, as the inside cells start to die, it says it has the appearance of kind of a Swiss cheese look on the inside of it. That's why it's holding some cheese. Now, diagnosing someone with tuberculosis, well, they can do an acid-fast smear. Again, looking for that pink bacteria. It's kind of pinkish purple, but that pink bacteria, usually from some type of sputum sample. They can culture out, they can grow the bacteria. They can do genetic probes looking for their specific DNA of this bacteria. And they can also do the tuberculin skin test, which some of you have had, where they put small, non-infective antigens of TB. And if you've been exposed to TB in the past, you have antibodies. Antibodies are going to react with those antigens they put in, and it's going to show up as this on your arm. I'm guessing none of you have that when you had your TB test does, but it identifies those who have been exposed to the bacteria. It doesn't mean they have an active infection, but it means at least they've been exposed to it at some point. They can also do chest x-rays and actually look for those tubercle growths. Now, tubercle growth itself might look like cancer or something else. They would do more testing, but it gives a snapshot of what it could be. Now, treatment for tuberculosis is hard. Most common antimicrobials that are usually given for bacterial diseases are ineffective. It's hard to treat. They have to use some really, tough antibiotics. Again, part of it is just because of that mycolic acid, that lipid in that membrane, that it's usually a combination of antibiotics that's given for usually 6 months or more. You're on a long-term antibiotic. Now, best prevention, if you're working in areas where there is big outbreaks of TB, we do have a vaccine named after the people that came up with it, but we do have a vaccine. Otherwise, your best bet is if you're working with patients with that TB, that they have some type of covering over their mouth, you have some type of covering over your airway, and all your proper PPE. Another mycobacterium that can affect humans, pretty rare, is the Mycobacterium leprae. It causes the more common disease just known as leprosy. Interesting part about this bacteria, it grows best in the cooler regions of the body, the extremities. Main reason this bacteria grows best at around 30 degrees Celsius. So it likes the coolest regions of the body, the ones that have the lowest blood flow. So fingertips, ears, toes, ends of noses, things like that. And I'm like, it's also really hard bacteria to grow. It's very picky, but because of its the temperature it likes, we can actually grow this bacteria in armadillos, whose body temperature is 30 degrees Celsius. So that's why I've got the armadillos link on there. Is we commonly use armadillos to grow this bacteria. It's a rare bacteria to have. It's spread person to person, skin to skin contact, usually with a break in their skin. Otherwise, it can be spread through nasal secretions. Again, it's hard to treat. It's usually going to be same thing as TB, combination of antibiotics for a long time. And finally, our last gram-positive bacteria is Mycobacterium avium-intracellulare, or shortened to Mycobacterium avium complex. It's the most common mycobacterium infection in AIDS patients, even above TB. Generally, it's picked up from ingesting contaminated food and water. It's a bacteria that's out there. It's not super common. Problem with this bacteria is that it gets inside of cells. All these little pink things, I know it's gram-positive, and I'm like, but all these little pink things are bacteria that are getting inside of cells, and they destroy the cells. They will lead to full organ failure. So it's not a good thing wherever the bacteria goes. And same thing, it's hard to treat. It's figuring out what antibiotics work, a combination of antibiotics, a little trial and error, and see which one works. But it's a tough bacteria. Luckily, it's rare. And it's even rarer for those that have healthy immune systems. All right, so there's the end of the PowerPoint.